Welcome to the DIY Honda Garage channel. DTC P0133 indicates a malfunction in the air-fuel ratio sensor 1, which is crucial for regulating the air-fuel mixture entering the engine. This sensor is mounted on the exhaust manifold before the catalytic converter, allowing it to measure the oxygen levels in the exhaust gas. This data is vital for the powertrain control module, PCM, to adjust fuel delivery for optimal engine performance and emissions control. If the sensor's responsiveness is low over a specified duration, the PCM interprets this as an issue, triggering the check engine light and storing this diagnostic trouble code. It's essential to address issues related to this sensor promptly, as they can lead to poor fuel economy, increased emissions, and potential engine damage over time. The air-fuel ratio AF sensor, specifically sensor 1, plays a critical role in monitoring the ratio of air to fuel in the combustion process. Located before the catalytic converter, this sensor measures oxygen content in the exhaust gases and relays that information to the powertrain control module, PCM. The PCM utilizes this data to adjust the fuel injection for optimal combustion, ensuring efficient engine performance and emissions control. A fault in this sensor can lead to incorrect fuel mixtures, causing issues like rough idling, reduced engine efficiency, and increased emissions. The performance is monitored through the sensor's responsiveness, and if this value is below acceptable limits, the PCM will catalog the DTC P0133, indicating a malfunction or slow response from the sensor. There are several potential causes for the DTC P0133. Firstly, a faulty AF sensor can be at fault. If it fails to produce accurate readings, the PCM will not receive the correct data to manage fuel delivery. Secondly, wiring issues, such as short circuits or poor connections, can disrupt the signal sent to the PCM, leading to erroneous readings and triggering the DTC. Additionally, although less common, problems with the PCM itself can occur, which may involve malfunctions in processing the AF sensor data. Proper diagnostics will help identify these causes effectively during troubleshooting. When DTC P0133 is set, there are several symptoms that drivers may experience. One of the most immediate indicators is the activation of the check engine light, signaling the need for inspection. Additionally, there may be noticeable drops in fuel economy due to inefficient fuel-air mixtures caused by the malfunctioning sensor. Drivers may also experience engine performance issues, such as rough idling or stalling, especially during acceleration. Emissions may increase as a result of improper combustion, potentially leading to failure in emissions testing. Recognizing these symptoms early can facilitate prompt repair, helping to maintain vehicle efficiency and compliance with environmental regulations. The first troubleshooting step for diagnosing DTC P0133 begins with starting the engine. Once the engine is running, hold the engine speed at 3,000 RPM without any load. This means ensuring the continuously variable transmission, CVT, is in park or neutral, or if it is a manual transmission, it should be placed in neutral as well. Maintain this engine speed until the radiator fan activates, which signals that the engine has reached its operating temperature. After this, allow the engine to return to idle. This step is crucial as it prepares the vehicle for subsequent testing of the AF sensor's functionality. Moving on to the second step of troubleshooting, the next task involves test driving the vehicle under precise conditions. The engine coolant temperature ECT sensor 1 should read above 158 degrees Fahrenheit or 70 degrees Celsius. During the test drive, if you are using a CVT, place it in drive. For a manual transmission, select third or fourth gear. Maintain the engine speed between 1,500 and 3,000 RPM. It's vital to drive at a steady speed of 25 miles per hour or 40 kilometers per hour or less for the first 5 minutes. This represents optimal conditions for the PCM to evaluate the AF sensor's response before switching to a higher steady speed of 26 miles per hour or 41 kilometers per hour or more for at least 8 seconds. This process is essential to test how the AF sensor operates under real driving conditions. In the third troubleshooting step, monitoring the onboard diagnostics, OBD status is required for the newly executed test drive. Utilize the Honda Diagnostic System, HDS, and look for the specific OBD status related to the powertrain control module, which is referenced as PGM-FI. The goal is to check whether the DTC P0133 remains stored after performing the previous steps. Carefully analyze the output from the AFAT sensor during the drive to determine if it showed responsive readings corresponding to the PCM's expectations. If the P0133 code persists, this indicates that further investigation into the AFAT sensor and its associated wiring is necessary. After completing the repairs suggested in the diagnostic steps, it's crucial to conduct a final repair verification to ensure that everything is functioning correctly. Start by confirming that the repairs have been successful, specifically verifying the condition of the AF sensor and inspecting the wiring for any damage. After this, check if any DTCs remain in the system. Clear any stored codes and prepare for another test drive to closely monitor the AF sensor's performance under similar conditions as before. Ideally, the initial symptoms should no longer be present, and the vehicle should operate smoothly without triggering the check engine light. To prevent the emergence of DTC P0133 in the future, implementing preventive maintenance is vital. Regular checks of the AF sensor can catch any signs of wear or faulty readings before they escalate into more significant issues. Additionally, keeping a close eye on the vehicle's electrical system, including wiring integrity and connections, will help prevent signal disruptions that could lead to sensor malfunctions. Regular maintenance of engine performance, such as oil changes and air filter replacements, is essential for overall efficiency and can indirectly benefit sensor longevity. An informed driver who monitors these aspects of their vehicle can significantly enhance their driving experience and ensure compliance with emissions regulations. In closing, understanding DTC P0133 is crucial for maintaining optimal performance and emission standards in the Honda Civic 2022 Plus. The AF sensor plays a vital role in managing the air-fuel mixture, impacting engine efficiency and environmental compliance. The key troubleshooting steps include evaluating the sensor's functionality through a controlled test drive and monitoring its response. By identifying potential causes such as faulty sensors or wiring issues, mechanics can address the problem effectively. Furthermore, adopting preventive strategies significantly enhances the reliability of the vehicle, allowing owners to avoid costly repairs and maintain smooth operation. By following these guidelines, drivers can enhance their understanding of their vehicle's performance and ensure its longevity. Please like and subscribe to the channel. See you next time.